Hi everyone, my name is Adeline, and I'm really happy to contribute today to this session, even though I'm not here live. I'm a registered architect, registered in the UK, but I work in Hong Kong. And most of my work is project management, and it's cool to see what AI can do from a client's perspective. I also have projects on AI, which some are design related and some are not. And I'm super excited today to show you guys what Finch can do. Finch is not the same as Stable Diffusion and Midjourney and LookX. It is not a diffusion model that creates images for us. Images are not the product for this. So Finch actually allows us to make decisions when we're designing floor plans. And for us architects, that's one of the things that we produce for clients, and it's really quite important. So Finch is rather an early stage feasibility tool, and it helps us with dealing with intelligent massing data, and which then allows us to make informed decision making by giving us the different scenarios, the different outcomes that we normally have to manually create. Now they're using machine learning um, to show us all the scenarios, and we can just be the person to make the decision. And if we think about the pain points as an architect or a designer of space, right? We spend time playing around with where the cores need to be, where the stairs need to be, the thickness of the walls, calculating area. How many people here spend time clicking on boundary areas in CAD just to put area numbers in an Excel sheet? Because I'm definitely one of those people in the past. The thing is, we have to go back and forth with the clients to redo some of the work of a floor plan if the client's not happy with, like, let's say the unit mix. So Finch can really help us with that. And I think I need to also mention right now, at the beginning, that one of the limitations that I can see in Finch is that the structure and the building services data, they're not incorporated into the platform. It's not like Revit, but in a way that's okay because, like I mentioned, this is meant to be an early stage feasibility tool. And personally, I find it really helpful for me to find out which plan to further work on in another software. And they're fully incorporated into Revit and Rhino as well. So that workflow works. All right, so I have some slides to show you guys. The co-founders of Finch are very supportive and have provided me some help to show you guys what the future looks like. Actually, the future is already here. All right, so let's get into it. So this is how the general workflow of Finch works. We would start in our own software, whether it's Rhino or Revit, and then we will prepare the exterior shell of the building so then we can upload onto Finch. And what Finch does is it handles the interior of the building in three ways. There's the massing studio, there's to generate floor plates, and the generate unit plans. So those are three different studios. For massing, it means that we can work with the story heights, the data calculations, and the wall widths. And for the floor plates, we can generate the layouts of the stairwells and a unit distribution. For the unit plans, so this actually is very helpful if we want to make our own unit module or build our own unit library. It's almost like making our Lego blocks, so then we can keep reusing them in different projects even. After that, we can then iteratively work through our building design and eventually export into BIM and CAD. So I think they actually allow us to work in a couple of different standard typologies. So this is also where I would say if we're designing something that is really specific, like a museum or like something like a fancy boutique shop, for example, Finch is not for that. I think Finch is really great for residential projects, great for hospitality and master plans, but not necessarily for something that's very bespoke. But that's my opinion. But it's great for these ones. Like so anything that requires modularity, I think it's really helpful. So the three different features that I just mentioned, the massing, the floor plates, and the unit plan, we can consider them as three different levels of details. When we generate the floor plans, actually we can work with our custom core. We can put cores specifically to where we want them to be, and the algorithm would actually help us to work the units around the cores, or we can start completely from scratch with nothing, and we can just actually need to find a central line of a floor plan, and Finch can actually work from there as a starting point. What it's able to do is to find out all the scenarios for us. So consider like there's one plan, one adaptive plan, and it is finding out all the configurations that works best around the plan. And this is reacting to where we put the cores, for example, reacting to different parameters that we set, like the wall widths, or the minimum size of a unit, which might be a limitation, might be a requirement from the client's brief, for example. So it helps us with those parameters and gives us the scenarios. So we can actually use our own library. As I was just mentioning, we can build our own library of modules, library of unit plans, or there are also something available in the Finch dataset. Yeah, so this is just a representation here to show the relationship between the constraints, the furniture accessibility, and space classes. And there's also a view where we can toggle to see the relationship between the space. So that's pretty interesting to see. I think it's very valuable because it really just saves us so much time in design. Things that we don't specifically enjoy doing, perhaps like offsetting from the center line of a wall, calculating areas, redoing things, making sure the door is, wherever, like left swing, right swing, all of that mundane stuff. If AI can help us, I would highly encourage us spending some time to explore that. Okay, so you can screenshot this if you want, and we can talk more about it later. But right now, let's go into a live demo that I can show you on Finch. So if we want to find out which building typologies work with Finch massing tools and floor plates algorithm, we can take a look at the Finch guide where they explain to us if we have rectilinear, voids, courtyards, angles, H&T shapes, and curved typologies. The massing tools would be a great help. But if we want to utilize AI floor plates on the curved designs, that's going to be a bit of a problem. So that's why I mentioned that if you have a museum design or something very bespoke, Finch is not really the tool for that. But for something like repetitive modular residential units, it is what it's for. Okay, so let's load up a floor plan. Here's a sample massing, and we're picking one of the floors, one of the stories. On the left, sorry, on the top, you'll see, okay, this is the massing studio, the massing tool, where we can go and see the blocks. But here we are in the building plan editing mode. Let's click onto the space. And here you see it's already set as residential, but you can choose for it to be something else. And in order for the parameters to pop up, we need to we need to press generate floor plan, but actually on the right, you can already see how it would be represented. So whatever that would be generated within this range would have this color. So these are the color coding for the different size of units. So this is where we can also see the different story heights. You see the little massing model here. If it's 3,000 floor heights, it will show itself as pink. And if it's for 4,500 millimeters, it would be shown as green. Here, after we clicked onto the space, we can just hit generate floor plan. So this is where we can control the unit mix. So I'd like to have some round numbers as my targets. Let's say, shall we go with something like this? Maybe it's 25, 25, 50%. That would be the ratio of my unit mix. And we would have units of 25 meters square, 40 meters square, and 60 meters squared. So I'm going to control where the stairs are going to be. I would prefer the stairs to be, let's say, on this side. So this is the stairwell attractor where it just attracts where the stairs are going to be on the floor plan. So it's doing its job and it's trying to match the sizes that we're asking for. On the left, there are many, many different parameters that we can take a look at, like the story weights, how much do we want it to follow the unit weight. So the different preferences need to be balanced, and we can choose what we prefer more. Do we want it to be, do we care more about the repetition or do we care more about the shape awareness? Actually, we do care about repetition because the more modular it is, the more cost efficient it will be. So let's just up that. Um, for example, in dimensions, we can also change the wall width. So let's say this is going to be 150 millimeters. Right. So it's just recalculating itself again. So let's proceed with units. I think what's happening is that it is struggling with the fact that I've asked it to repeat itself quite a bit. So I'm going to lower this to lessen its burden in this process. So it's just recalculating. Right. So what we can see here is that it has generated two different stairwells for me. They've tried their best. The algorithm had tried its best to do what I've asked it to do. So let's take a look at what if we change this percentage. Let's say, let's flip this around. Let's say I would like more smaller units and less larger units. So let's see what it's going to do. It's recalculating itself. If we zoom in a bit, we can see the labels and later on we can also apply different unit plans onto these boundaries. Let's take a look again. Right, so these are our different categories. Let's apply plan. So now we have this plan that we can further manipulate. So if we go into this here, you will see how it looks like in where it's located, I mean, in the massing model, and we can edit the units. We can actually begin to draw our units manually, or we can actually apply saved presets modules onto these units areas. So let me just flip over to this here to show you what that would look like. So for example, we can see that these two plans here are the same. We have this, we can further manipulate it more. We can see how in this unit, there's the living room, the kitchen, the bathroom, the bed, the two bedrooms, and the corridor. So everything is changeable and everything is editable. But this right now is saved like a family, like if like Revit family, I mean, that's how I think of it. So it can then be further updated if we want to. So I'm showing you guys the library, the floor plan library. So for example, if you go into this one here, you can see we can further edit it as well. Do it right here. Let's say shifting it by 200. Uh, Not that we want this to happen, but that's just to show what we can do to manipulate the walls and the location of things. So it's very user-friendly. Maybe move it over here, for better circulation here, etc. Right, so I hope you guys find it interesting as well. I really see the value in the tool and other similar tools as well, like whichever AI that can automate and make our lives easier. I'm very supportive of it. And in turn, Finch had been supportive of me and presenting this today to you guys. So if you watching this, you are interested in accessing Finch, do use this code for a 50% discount. This code applies until the 26th of September. So I hope you guys find it interesting. Thank you so much to Digital Futures and to Neil for giving me this opportunity to show you guys some very cool stuff out there. And I hope to see you guys soon. Bye.